Air pollution. Chapter 5. Control of air pollutants. Air quality standards. Air quality standards are provided by many groups and organizations such as National Environment Protection Council Standards, WHO, US EPA, NSW/EPA/DEC Standards, Standards Australia. Control of air pollutants. Particulates. Particulate matter, the most obvious form of air pollution, therefore receives the most effort in pollution reduction measures. Process modifications. Fuel substitution. Encapsulation and wet operation can also greatly reduce the amount of fugitive particles emanating from a potential pollutant source. Control of air pollutants. Particulates, cyclones. Separation by centrifugation, most common form of particulate removal. Gas is spun rapidly, heavier particulate matter to collect on outside of separator by centrifugal force, where it is collected and removed. Cyclone separator. Control of air pollutants. Control of air pollutants. Particulates, filtration. Fiber bags commonly used for control of particulate emissions with very high dust loadings and smaller particles. As the gas changes direction, large particles are removed by inertial separation and collected in the hopper. Dust is collected on the inside of the bag surface and the filtered gas is discharged to the atmosphere. 99% efficient. Control of air pollutants. Control of air pollutants. Particulates, wet scrubbers. Spray systems where fine water droplets are sprayed at high velocity at right angles to the emerging gas. Most of the particles in the gas stream are scavenged by the water droplets, which fall and are collected along with the particles. Relatively low efficiencies, 80 to 90%, and is usually employed as a pre-cleaner to remove particles larger than 5 m. Control of air pollutants. Control of air pollutants. Particulates, electrostatic precipitators. Pass dirty gas through a series of fine wires, coronas, charged with DC current, causes particles to coalesce and precipitate. Alternatively, corona produces negative ions that cause particles in the gas stream to become negatively charged, and attracted to positive terminal, where they coalesce and fall into a collection hopper. Large precipitators and low gas flow rates give better results. Control of air pollutants. Control of air pollutants. Gaseous pollutants, process modifications. Simplest and least expensive methods for the control of gaseous pollutants. Fuel substitution, for example low sulfur coal, or fuel oils in place of cheaper coal, can greatly reduce the amount of SO2 emissions at the source. This type of source control is always the best approach wherever possible. Control of air pollutants. Gaseous pollutants, combustion. Involves a series of complex chemical reactions in which oxygen is combined with organic molecules, to form CO2 and H2O. Commonly referred to as incineration or afterburning. Afterburning is applicable when the treatment process is located downstream of a primary combustion process. Control of air pollutants. Gaseous pollutants, combustion. Incineration applied to effluent streams containing combustible gases. Incineration can be used to eliminate malodorants such as mercaptans and H2S. Organic aerosols and visible plumes such as those produced by coffee roaster and enamel bake ovens. Combustible gases produced by refineries, and solvent vapors produced by a variety of industrial processes. Control of air pollutants. Gaseous pollutants, combustion. 3 types of combustion systems commonly utilized for pollution control: direct flame, thermal, and Catalytic incineration systems. Control of air pollutants. Gaseous pollutants, adsorption. Physical adsorption to solid surfaces. Reversible, adsorbate removed from the adsorbent by increasing temp, or lowering pressure. Widely used for solvent recovery and dry cleaning, metal degreasing operations, surface coating, and rayon, plastic, and rubber processing. Control of air pollutants. Gaseous pollutants, adsorption. Limited use in solving ambient air pollution problems, with its main use involved in the reduction of odor. Adsorbents with large surface area to volume ratio, activated carbon, preferred agents for gaseous pollutant control. Efficiencies to 99%. Control of air pollutants. Gaseous pollutants, absorption. Scrubbers remove gases by chemical absorption in a medium that may be a liquid or a liquid-solid slurry. Water is the most commonly used scrubbing medium. Additives commonly employed to increase chemical reactivity and absorption capacity. Control of air pollutants. Control of air pollutants. Gaseous pollutants, dry scrubbing. Used to remove large amounts of SOx from flue gases using a dry alkaline absorbent, usually lime or sodium carbonate. Several advantages over wet scrubbers. Do not suffer from scaling or residue buildup. Do not require elaborate sludge handling systems for waste materials. Less maintenance as there is less corrosion. They use up to 50% less power and water. Control of air pollutants. Gaseous pollutants, odor. The main approaches include wet scrubbing, charcoal filtration and incineration. Control of air pollutants. Gas pollutants, vehicle emissions. Generally involve simple procedures such as maintaining the correct tuning for the engine, or the use of catalytic converters. Catalytic converters use PT and PD attached to some form of ceramic material. Extremely high surface area, in hundreds of m2, allows catalytic materials to contact exhaust gases, oxidizing them to CO2 and water vapor. Control of air pollutants. Gas pollutants, vehicle emissions. All the measures which decrease CO and hydrocarbon emissions, increase NOx emissions. Measures such as changing engine spark plug timing and reduction of compression ratios allow NOx emissions to be lowered without greatly increasing other pollutant emissions.